This video contains a description of the concept exponential growth and decay. We will add the use of graphs for a visual understanding of exponential functions activity.
We will explain two real-life cases where exponential functions are implemented, one with a constant increment and another one with decay.
Also, we're giving a brief summary of Chernobyl's nuclear reactor disaster to this day and in a global context. The purpose of this video is the total knowledge of exponential functions.
An exponential function, in a mathematical way, is written as f of x equals a to the power of x. F of x equals the base to the second power, where x is a variable and a is a constant called the base. Exponential growth is the acceleration of the increasing number or size in proportion to a constantly growing rate. It is when the original amount is now growing at the same rate within an amount of time. Exponential growth can be used to determine the values of investments, values of retail, and much more. The shape of the exponential growth graph is a simple half parabola approaching the axis, but it will change according to the numbers that are entered, either into a wider or narrower graph. Since we're talking about exponential growth, it will be a continuously rising curve. There can also be exponential decay, which would be the same, but instead of increasing, it would be decreasing.
Case 1. Atmospheric pressure. The pressure of air around you decreases as you go higher. An excellent example of Mount Everest, which decreases about 12% for every 1,000 meters. It's an example of exponential decay. The pressure at sea level is about 1,313 HPA, depending on the weather. The formula to find the pressure at a certain altitude in Mount Everest is y times t equals a times e to the power of k times t, which a is the pressure at sea level and t is the distance in meters. So now we know that when the altitude is 381 meters, the pressure would be 965 HPA. And then when the altitude is 8,848 meters, the pressure would be 327 HPA.
As most people know, in April 26, 1986, Chernobyl suffered a huge explosion. Let me explain this in a more detailed way. Chernobyl is located in the northern part of Ukraine, and where the nuclear plant is found. This was built in the 1970s with the purpose of producing electricity. It is composed by 4 reactors.
Previous to the disaster, it was planned to shut down reactor number 4 and see how much time did the plant kept working. This was planned under the directions of Moscow.
What happened first was that extremely hot nuclear fuel was lowered as mechanisms were disabled. This caused the release of a huge amount of steam that further caused the explosion of reactor number 4 and the release of radiation into the atmosphere.
After the explosion, the government held an investigation to know the causes of the explosion. At the same time, the evacuation of the population started. However, the release of radiation affected the health of many and even deaths. The most common symptoms were headaches, vomitings, hair loss, fever, and diseases such as thyroid cancer increased in Ukraine.
Thanks to the strong winds at that time made the radiation to move from south to east. Radiation not only affected humans but also animals and plants. It killed many trees by changing its appearance to a ginger color because of the high levels of radiation. Nowadays, in Chernobyl can be found many unique species. It is thought that they have adapted to high levels of radiation, since they have a high level of cesium-137.
This is an example of a real-life case exponential growth. This is the formula. Letter A represents the new amount. Letter P represents the actual amount, R represents annual growth percentage, and T the years covered. In this case, we're measuring the population growth from 2000 to 2017. So if we place the values, the formula will be 6,150,000,000 times E elevated to R times 17. We're missing the percentage. For it, we're isolating letter R. For this, we need the actual population in 2017, which is 7,600,000,000. As we isolate for R, we pass the value of 2000 population to the left, dividing the actual population. The result will be 1.2357 equals E to the R times 17. Then we have to get rid of e, so we will use the concept ln. In the left side of the equation, we will have 0.2116, and in the right side, we will have r times 17. The last step will be to pass 17 to the left side and divide 0.2116. The answer will be 0.012, represented as decimal form. So the percentage will be 1.2. The final equation will be A equals 6,150,000,000 times E elevated to 0.012 times 17. This is not an accurate graph, but here we can tell the increasement of population from 2000 to 2007. We obtain each year value by subtracting any of the wanted years from 2000, and the answer was replaced in letter T, which represents years in the formula. These are the results from each year.
Tricks like Scarface and Bushwick, Willie D having nightmares of girls killing me. She mad because what we had didn't last. I'm glad because her cousin let me hit the ass. Fuck the past, let's dwell on the 500 SL, the E and J and ginger ale. The way my pockets swell to the rim.